So here we start the next chapter, Thermodynamics. Chapter 1 completed. 3 topics. One is MO and related to MO diagram, all these things. Questions also I have discussed. Then you have the next topic, crystal free stabilization energy, and the third topic was semiconductors. These 3 topics, whatever I taught, that is your syllabus. Okay, don't need to study anything else. Whatever I taught, that is the syllabus. Then coming to thermodynamics. Thermodynamics, to start with, we need to understand what are the system, process, surrounding, some basic definitions. System is anywhere I confine my attention. That is my system. If I'm busy with my computer, then the computer itself is the system. The monitor, the keyboard, the mouse, everything is the part of the system. Because I am confined there, then that is the system. When writing something with chalk and duster into the board, then the chalk duster is my system. When I am writing with pen and paper, then pen and paper is my system. But whatever you are writing, that is process. Okay, here I am typing something. So there, the hardware or whatever hardware is there, that is my system. But whatever I am doing, that is the process. So process cannot be touched by hand, but system can be touched. If water is boiling into a beaker, that is my system. But the boiling phenomena is the process. Okay? You can understand the boiling is going on, but can you touch boiling? You can touch the water, but not the boiling. So that is the process. So this is the difference between system and process. Apart from the system, whatever you have in the vicinity, surrounding, system, surrounding, and process. Now there can be a lot of different type of system. For example, the open system, closed system, isolated system. Open system means where your energy and mass both are exchanged between the system and the surrounding. That is called open system. For example, us, we are open system. Living beings. Living beings are open system. When we inhale, air is going in, and when we exhale, air is going out. But obviously there is a exchange, because we are accepting oxygen from the air and we are releasing carbon dioxide into the air. So we are taking something and releasing something else. So mass is changed. Energy also, because when you inhale cold air, when you exhale it is hot air. So energy is also exchanged. So mass and energy both are exchanged. So it is called open system. Boiling water into a beaker, also open system. Now closed system, the example can be, crude example can be, the boiling water into a beaker and it is closed by some lid, and where the steam cannot go out. Okay, that type of system. It can be some enclosed vessel, like pressure vessel, like pressure cooker. Okay, so these are closed system where the mass cannot be exchanged but energy can be exchanged. It's called closed system. Then a third one, it is called isolated system. A very good example can be thermoflask, but though not exact example, theoretically possible, but practically that is not possible. Isolated system. So here, what you have, neither mass nor energy can be exchanged with the surrounding. That is called isolated. Okay? Neither mass nor energy can be exchanged with the surrounding. That is called isolated system. So this is open system example. You have a container. In that container you have some gas or something. So there is some quantity of mass, and when it is open, the lid is open, gas can go out. That is open system. But if it is closed in such a way, heat can be taken in or it can go out, but no matter can come out, then it is a closed system. And open cup of coffee is open system, closed cup of coffee is closed system, like that. Capped cup of a coffee, tightly capped, it is closed system. Isolated system, insulated thermos bottle, as I told you, thermoflask. That is the example of isolated system. Now properties can be different properties of a thermodynamic system. Okay, different properties of thermodynamic system. Some properties are called intensive property, some are called extensive. Intrinsic property independent of mass or quantity. Independent of mass or quantity. That is called intrinsic property. For example, surface tension, viscosity, refractive index. These are not dependent on amount. If you take one glass full of water and one bucket full of water, both the cases, the surface tension, viscosity will be equal. So this type of property is called intrinsic property. Intrinsic property independent of mass. Both are containing in. So you can easily remember. Intrinsic property independent of mass. Extrinsic property mass dependent. Mass dependent property, for example, volume. Volume depends on mass. If you take certain quantity of mass, you have got certain volume. Double the mass, volume will be supposed to be double, isn't it? So volume and mass are related that way. So that means it depends on quantity or mass. This type of property is called extrinsic property. Specific properties. Per unit mass of a fuel or material, any property that you consider, if I take a fuel, the amount of energy released by burning unit mass of a fuel, that is called calorific value. So it is a specific quantity. Specific means it is definite one. Okay, so usually specific means per unit, so that we can compare. Specific heat capacity, specific resistance, specific conductance, this is called specific. Now if I say molar, that is per mole, specific is per gram. State, how many states of matter you know? 5. Solid, liquid, gas, plasma and Bose-Einstein condensate. The fifth one, Bose-Einstein condensate, is actually theoretical one and artificial one. But others are all natural. Solid, liquid, gas and plasma, all are natural. Now can you tell me which state is maximum present in nature? Out of all the states, which one is present maximum in the nature? Solid, liquid, gas, plasma, which is maximum in nature? Plasma. Plasma is maximum because you see, sun and others, this planetary system in the solar system. Which one is more quantity? Sun is larger or planets are larger? Tell me. How much larger? Very high, no? So compared to all the planets together, sun is larger. So you go for any other star, they are also the same thing. Sun is plasma, all the stars are plasma, all the galaxy, if you consider, then plasma is maximum. Okay. Now next one will be what? Gas. Then solid and then liquid. Liquid is less. Okay, so liquid state is rare. Now this is state. Now what is phase? Here there is a term, phase. Let's take example. Diamond, graphite, coal, carbon black, all are solids. State wise they are all solids, but they are not same. Diamond and coal, are they same? You will accept one piece of coal with exchange of diamond. It is not same at all, but still both are solid. So they are in two different phases. I think now we understood. Another one, you have sulfur, alpha sulfur, beta sulfur, rhombic and monoclinic. They are both solid, but they are not same. They are in a different phase. Same state, but different phase. Not only that, into a particular state, there can be multiple phases. Semi-solid, it is a phase. Semi-solid is not a state. Solid is a state, liquid is a state, but in between, if you can, multiple number of situation can arise. Semi-molten condition, that's a phase. It's not a state. So state is very well defined, and phase means you have two different property, and there is a boundary. Beyond the boundary, you have got two different property. Then inside the boundary, you have got one phase. Outside the boundary, you have got another phase. Understood? You have got a boundary wall. Inside the boundary, suppose you got certain property. So it is in one phase. Outside the boundary, you get some other property, not same property found. Then it will be said to be in a different phase. What is equilibrium? Equilibrium, for example, reversible reaction. The same rate, forward and backward reaction is going on. Then it will be said to be an equilibrium. So equilibrium is established. What is steady state? The water is flowing into a chamber or in a bucket, and the same rate water is flowing out also from the bucket. So at the same rate the water is coming in and it is also going out at the same rate. Then what will happen? The quantity of the water in the bucket will be constant. Very good example is swimming pool. Constantly water is coming in and going out at the same rate when the swimming pool is in operation. So that is called a steady state, but it is not equilibrium. Equilibrium means the same thing is recycled again and again and again. Steady state means it is coming in and going out at the same rate, more or less constant, okay, but it is not recycled. That is the difference, steady state and equilibrium. What is a process? What is a process? Process can be so many. One is called isothermal, isobaric, isochoric, reversible, adiabatic, irreversible. So many names. So you have to understand one by one. Isobaric means pressure remaining constant throughout the process. Isochoric means volume remaining constant. Isothermal, temperature remaining constant. Adiabatic, no heat exchange between the system and the surrounding. Reversible, process happening in a very slow and minute stages, so that reversal is very easy. Irreversible process, the step is very large. Once it's coming down, climbing up will be difficult. Then is irreversible. One way direction. Water falling from the rooftop to the ground. Okay, it happens sometimes when you just use our pump. Sometimes it is getting filled from the tank. Water is flowing downward, right? That water will automatically not go at the rooftop. You'll have to use the pump again to get the water back to the rooftop, right? So it is not by itself. You have to forcefully do it with certain energy, expense of certain energy. That is called irreversible. It is not getting reversed back by itself. But reversible, it can easily go back. Some ice is melting. Little bit of temperature variation is melting and it can be frozen again. So easily. It is always in equilibrium. That is called reversible. When the system surrounding equilibrium always exists, that is reversible. And that such equilibrium does not exist, it is irreversible. Okay, I end up here today.